Okay, so now we're going to take a look at writing the equation for the axis of symmetry given an equation as opposed to a graph. So again, the first thing that we want to do is figure out what information we have. Do we have the intercepts, do we have the vertex, or is it in standard form? This time it is in standard form. If you don't see any parentheses, that kind of gives you a clue that you're in standard form. So then you use the information you have to find the x-coordinate of the vertex. In this case, for standard form, we're going to use the formula x equals negative b over 2a. So remember, standard form is ax squared plus bx plus c. A is the coefficient of our x squared. In this case, we are multiplying our x squared by 1. If you don't see a coefficient, you are multiplying by 1. B is the coefficient of our x, or 7. And we don't need our c to find the x-coordinate of the vertex. So, equation for the axis of symmetry. X equals negative b over 2a, or negative 7 halves. So the equation for the axis of symmetry is x equals negative 7 halves. Now remember, that's a vertical line that you place on the graph, goes through the vertex, and it's the line across which the graph can be reflected. Next, identify the domain and range. Domain for any quadratic function is all real numbers. To find the range, we need the y-coordinate of the vertex, which means we substitute the x value of the vertex back into the function and solve for y. Alright, so negative 7 halves squared gives us 49 fourths. Most of you would do this with a calculator. And then I am subtracting, that much to go away, 49 halves plus, I'm going to convert that to a common denominator with my first term. I'm going to convert the middle one to a common denominator as well, so that I can get the y-coordinate for my vertex. Actually, to extend the page. So we get the 49 plus 48 gives us, let me double check my math, 97 fourths minus 98 fourths will give us negative 1 fourth. So that's the y-coordinate of our vertex. In order to determine if its y is greater than or equal to or less than or equal to, we need to know if our graph opens up or down. So when we look back at the original function, our x squared term is positive. It has a positive coefficient, so the graph opens up. So therefore, y will be greater than or equal to the negative 1/4, that y-coordinate of our vertex. All right, one more, and then we're going to move on to something else. So we're going to be writing the equation for the axis of symmetry again. This time we're given vertex form, so it's going to be fairly straightforward in this case. This, remember, is the horizontal shift. It's in the asylum, so it's not normal, so the x-coordinate of our vertex is negative 3. So there's the equation for the axis of symmetry, x equals negative 3. Sorry, forgot this step. Step 1, determine what information we have. It's already in vertex form, so we have the equation for the axis of symmetry. So now all we have left to do is find the domain and range. For any quadratic function, domain is all real numbers. We also have the y-coordinate of our vertex because it's in vertex form. So y, we'll figure out this symbol in a minute. The y-coordinate of the vertex is 9. We need to figure out if our graph opens up or down to determine if it's greater than or equal to or less than or equal to. Here we have a negative, which means our graph opens down. So our vertex is a maximum, so y is less than or equal to 9.